Hello everyone, welcome to new class. Today's class is about the clipping circuits. So clipping circuits are the applications of diodes. So let us study about the clipping circuits. The property of a diode as a switching device is utilized in clipping circuits, and clipping circuits are linear wave shaping circuits. They are useful to clip off the positive or negative portions of an input waveform. It can also be used to slice off an input waveform between two voltage levels. Using a positive clipper, a moderate quality square waveform can be generated from a sine wave. And the diode clippers are classified as series and shunt clippers. If the diode is connected in series with the input in a clipper, such a clipper is called series clipper. If the diodes are connected in parallel with the input, that is this circuit, that clipper is called a shunt clipper. So here I am discussing about the shunt clippers. First one is positive clipper with clipping level at 0 volt. So this is the circuit diagram for positive clipper with clipping level at 0 volt. So here this circuit passes only the negative going half waves of the input to the output. That is, this is the input. So, and this is the input waveform. During the positive half cycle, that is during this positive half cycle, the diode is in forward biased condition. That is, the diode acts as a switch or closed circuit. So, the output, that is V out, will be a line here. And during the negative half cycle, that is during the negative half cycle, the diode is in reverse biased condition. That is, diode does not conduct, so it will be in open condition. That is, it acts as a open switch. So we will get the input, that is we will get the output across this diode. So we will get the output waveform as like this. So during the negative half cycle, the diode will not conduct. So the output across that diode will be the V in. That is, we will get the output like this. That is all the positive half cycles. Again, in the next positive half cycle, the diode conducts. Then it will be like this. Then during the negative half cycle, so it will be like this. Then again it will conduct. Then in the negative half cycle, the diode will not conduct, so it will be like this. So all the positive half cycles are bypassed through the diode because the diode gets forward biased. And due to the, so this is the theoretical expression for the positive clipper, but in practical case there will be some voltage drop across the diode. So if the voltage drop across the diode be, let it be 0.6, then the clipping occurs exactly at 0.6 volt, not at 0 volt. it will be at the voltage drop across the diode. So let it be 0.6 volt. Then how will be the output waveform? So in practical case, the clipping occurs at the voltage drop across the diode. So V out will be, so in the positive half cycle, let this be the 0.6 volt. Then up to the 0.6 volt, the diode will not conduct. So it will be like this. Then after this 0.6 volt, that is when the V in, this is V in, so when this V in is above this 0.6 volt, the diode will conduct. So that portion is clipped off. So after this, this is 0.6, so the waveform will be like this. Again, during the positive half cycle, it will be conducting. Then during the negative half cycle, it will not conduct. So this is the practical case for the positive clipper with the clipping level at 0 volt. So clipping level at 0 volt means this is the practical case. So actually it will be clipping at the voltage drop across the diode. Next is negative clipper with the clipping level at 0 volt. So this is the circuit diagram. So during the positive half cycle, the diode will not conduct. That is, it will be acting as an open switch. So we will get the output across this open diode. That is, output waveform will be like this. Then during the negative half cycle, the diode will be in forward bias condition. So it will conduct. That is, it will be like a closed switch. So we will get a waveform like this. Then again during the positive half cycle, the diode will not conduct. Then we will get the output like this. Again during the negative half cycle, it will be conducting. So in practical case, the clipping occurs at the voltage drop across the diode. That is, let it be this volt, that is, let it be 0.6 volt. Then clipping will be at 0.6 volt. So when this voltage is 0.6 volt, that is above this 0.6 volt in the negative direction, the diode is conducting. So we will get a waveform like this. Then again during the positive half cycle, it will not conduct. So this is the practical case. That is negative clipper with the clipping level at 0 volt. Next is positive clipper with clipping level at 3 volt. So this is the circuit diagram. So here a voltage of 3 volt is applied here. Then this is the input waveform. So here till the input becomes greater than 3 volt. Let this be the 3 volt. So till 3 volt, the diode will be in the reverse biased condition, and hence we will get the output. That is, we will get the input at the output up to this 3 volt. So this is 3 volt. So up to this 3 volt we will get the output. So it will be like this. So above this 3 volt, that is when the input is above this 3 volt, this diode will be in forward biased condition. So it will conduct. So it will be a closed switch. So we will get an output waveform like this. So up to this 3 volt. Then during the negative half cycle, it will be in reverse biased condition. Hence, we will get the output like this. Again, up to this 3 volt, it will not be conducting. So, we will get the output waveform like this. So, in practical case, we have to consider the voltage drop across this diode. So, it will be about, let it be 0.6, that is the voltage drop across this diode be 0.6, then up to 3 plus 0.6, that is 3.6, it will not conduct. So the diode will conduct above this 3.6 volt. So up to 3.6 it will not conduct. So we will get a waveform like this. So in practical case, it will be like this. So this is positive clipper with clipping level at 3 volt. Next is negative clipper with clipping level at 3 volt. So this is the circuit diagram. And here during the positive half cycle, the diode will not conduct. Hence, we will get the input across this diode. That is, it will be in open condition. So we will get the input across this diode, that is we will get the output as this. Then during the negative half cycle, up to this 3 volt, that is when it will be greater than minus 3 volt in the negative direction, then only this diode will conduct. That is up to this minus 3 volt, the diode will not conduct. Hence we will get the output waveform, that is input waveform across this diode up to this minus 3 volt. Then above this minus 3 volt in the negative direction, it will be conducting, that is the diode will be acting as a closed switch. So we will get the output waveform like this. Then again during the positive half cycle, it will not conduct, then we will get the output like this. So in the practical case, this 3 volt will be 3 volt plus the voltage drop across this diode. So let it be 0.6 volt. Then up to this minus 0.3 minus 3.6 volt, the diode will not conduct. Then we will get the output waveform like this. After that it will be conducting. So this is the waveform in practical case. Next is double clipper with clipping levels at plus 3 volt and minus 3 volt. So this is the merging of positive and negative clippers. So during the positive half cycle, this one will be conducting. That is here there is a voltage source, that is 3 volt. So up to this 3 volt it will not conduct. After, that is above this 3 volt, it will be conducting. So we will get a waveform like this. Then again in the negative half cycle, this one will be open, but this diode, that is diode D2 will be in forward biased condition. But here also up to this 3 volt it will not conduct. So we will get the output waveform, that is input waveform across this diode. So the output will be like this, that is up to this 3 volt it will not conduct. Then above this 3 volt this diode D2 will be conducting. So we will get a waveform like this. Again in the positive half cycle it will be like this. So this is plus 3 volt, then this is minus 3 volt. So in practical case, we have to consider the diode voltage drop. So in that case, it will be about a 3 plus diode voltage. That is here also minus 3 plus the diode voltage drop. So this is the case of double clipper with clipping levels at plus 3 volt and minus 3 volt. Next is two level slicer with slicing levels at plus 3 volt and plus 5 volt. So this is the circuit diagram for that. So there are two diodes D1 and D2. So this is 3 volt and this is 5 volt. Now during the positive half cycle, diode D2 will be conducting, but up to this 5 volt, diode D2 will not be conducting. So let this be 5 volt, then up to this 5 volt it will not be conducting, then after that it will conduct. Then during the negative half cycle, D1 will be conducting and D2 will be reverse biased. So during the negative half cycle, D1 will be conducting, but here there is a voltage source 3 volt. So this is positive 3 volt. Then here the diode D1 will be conducting below this 3 volt. That is below this 3 volt, the diode will be conducting. That is this is 3 volt, then this is 5 volt. So the waveform will be like this. That is during the negative half cycle also, here this diode D1 will be conducting during the negative half cycle. That is negative half cycle it will be conducting, but when this voltage source is up to 3 volt. So up to 3 volt, here this diode D1 will not be conducting. So it will be maintaining a voltage level between this 3 volt and 5 volt. So we will get a waveform like this. So here during the negative half cycle of the input, diode D1 conducts and D2 will be reverse biased. So during the negative half cycle, this 3 volt will be maintaining. So during the negative half cycle, this 3 volt will be maintaining here. So we will get a slicer at this level. That is the output waveform will be between 3 volt and this 5 volt. And if we are considering the voltage drop across these diodes, then what will be these values? So in practical case, here this is positive and positive. So 5.6 volt will be the upper level. Then here this is negative and this is positive. So we have to subtract. So here if this is 0.6 volt, that is the voltage drop across this diode D1 is 0.6 volt, then 3 minus 0.6 volt, that is here this voltage level will be 2.4 volt. So we will get a waveform between 2.4 volt and 5.6 volt. So this is about the two level slicer with the slicing levels at plus 3 volt and plus 5 volt. So that is about the clipping circuits. That is here we have discussed about shunt clipping circuit. So this is about the clipping circuits. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.